This video, we are learning about Ohm's law. What is Ohm's law? So initially we have discussed about electric current, electric potential, and electric resistance. Electric current we denoted with I, electric potential V, electric resistance R. So the relation between IVR we can call it as Ohm's law. Now, what is electric current? The flow of charged particles in unit time. What is electric potential? Work done by the charged particle. And resistance, opposition of flow of charged particles. The relation between IVR we can name as Ohm's law. In Ohm's law, how the circuit is designed? He has taken a long lead and short lead which indicates a battery. Battery has connected to closed switch. From closed switch to the ammeter to variable resistor, across variable resistor voltmeter, then again the fixed resistor, we made it as a closed circuit. Now, if batteries are increasing, once batteries are increasing, electric current also will be increased. So battery in the sense of potential, if V increases, electric current also will be increased. Yes, Ohm's law is applicable at room temperature. At room temperature, V is equal to IR. So the relation between IVR is V is equal to IR. This is Ohm's law. Now, experimental setup. In this circuit diagram consists of a nichrome wire of length XY, say 0.5 meters, diameter D, an ammeter A, and voltmeter, across nichrome wire voltmeter, and 4 cells of each 1.5 volt connected to the wires. Now, nichrome wire length 2L and diameter D. Nichrome wire length L, diameter 2D. Copper wire of length L, diameter D. So these are all the supplementary materials what we have chosen. So according to Ohm's law here, on x-axis and y-axis, if you take this, on y-axis potential difference, on x-axis electric current. Now, as you know that V is equal to IR. Now R is equal to V by I. As you know that the slope of a curve is equal to y-axis by x-axis. So that's the reason on y-axis we have mentioned as a potential difference, on x-axis electric current. So this is resistance R. So this graph will represent the resistance. Yes, there are a few questions I'm asking to you. I need answers in the comment box. What do you observe from the graph of activity? How is it nature? What does it suggest about relationship between V and I? Can you spot the difference between graph obtained in each activity? What's the reason of difference in current behind obtained in each case for the same number of voltage source connected? From these activities, you can suggest the factors on which the resistance depends. These questions, please answer in the comment box. Yes, let me see what you have understood. How much current will an electric bulb draw from 220 volt source if the resistance of the bulb filament is 1200 ohms? Option A, 18 amperes. Option B, 1.8 amperes. Option C, 0.18 amperes. Option D, 0.018 amperes. Right answer is 0.18 amperes. So how it works? As the given data, electric potential V is equal to 220 volts if the resistance of the filament is 1200 ohms. Now V is equal to IR, I is equal to V by R. Yes. Now 220 by 1200, if you do that, current will be 0.18 ampere. Next, how much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohms? Now electric potential V is equal to 220 volts and the resistance of a heater coil is 100 ohms. So I is equal to V by R. So V value 220 by 100. is equal to 2.2 amperes. So the right answer is option B. Next question. The potential difference between the terminals of an electric heater is 60 volts when it draws a current 4 amperes from the source. What current will the heater draw from the potential difference is increased to 120 volts? Option A, 2 amperes. Option B, 4 amperes. Option C, 6 amperes. Option D, 8 amperes. The right answer is 8 amperes. This answer is very simple. While using 60 volts, we got that 4 amperes. If you use the double of it, what about the ampere? Also will be double. As you know that V is directly proportional to I. Once potential increases, electric current also will be increased. Thank you for visiting channel.